Hello, my name is Michael Salka. This video presentation is my response to the challenge question for the Norman Foster Foundation Energy Workshop 2022 scholarship application. Thank you in advance for your attention. Currently, I am a PhD in architecture candidate at the University of Cambridge. I am funded by the Bill and Melinda Gates Foundation and serve as the external officer on the Gates Scholars Council. Prior to joining Cambridge, I studied for my master's in Advanced Ecological Buildings and Biocities at the Institute for Advanced Architecture of Catalonia's Valdara Labs facility, and then proceeded to work as head of projects for Valdara Labs. My approach to architecture and energy is based on the realization that as of the year 2020, the anthropomass, the total amount of objects made by humans worldwide, for the first time exceeded the planetary biomass. This is emblematic of the fact that we can no longer deny our role as primary shapers of the earth and the environment, and we must design our cities and our buildings accordingly, especially understanding the anticipated expectation for continued population growth worldwide, continued urban to rural migration, and of course continued climate change if we don't take mitigating actions. I start with 40% as this number that we need to pay attention to superimposed over the towers of Hong Kong, because 40% represents the contribution of buildings to global carbon emissions. This is true when we consider not just the energy and the carbon that buildings use in their operations to maintain internal temperatures and humidity and also to power appliances, but if we also consider the production of the built environment, the creation of building materials, their movement to sites, and the erection of these buildings. And currently, the building materials and construction, the embodied energy or carbon represented is less than the amount that's used during operation of the building, but as we're about to see, this is going to change dramatically. Looking forward, we can see that with the projected growth occurring and the fact that operationally buildings are becoming more efficient due to increases in energy efficient appliances, increases in glazing efficiency and in the sealing efficiency of building envelopes, the embodied carbon of the materials and the construction processes is expected to surpass proportionally the operational carbon. So this is where we really need to focus our energies and our innovation going forward. Of course, we have to keep in mind that we need to do this as a mandate, as a responsibility, because we're expecting global floor area, built floor area that is, to double by 2060. And of course, these are the same decades in which now over 130 nations have committed to achieving carbon neutrality. Fortunately, it's not too difficult to focus on what we need to solve, even if the solutions are not so easy, because only 3 of the primary building materials, concrete, steel, and aluminum, those most representative of the modernist era, account for 23% of global CO2 emissions in their production. So by finding innovative ways to substitute or improve these, we can do a lot of good for the world and the built environment. And this gives an immense responsibility to us as designers, as architects, as planners of the built environment. I now start with one of my first projects as an intern in Denver, Colorado, USA. I was fortunate to be able to engage with the production of the GEOS neighborhood, which was the nation's largest net zero master plan neighborhood, entirely powered by solar panels and by geothermal facilities. The plan includes 308 units, 29 of which have been constructed so far. The video that's playing in the lower right here is a segment from CNN that was extracted during the COP26 conference, which is showing that even in a scenario such as the United States where resources are available, at least financial resources, and in this case the energetic resources to power this neighborhood, there are still problems with entrenchment, with policy, and with standard practice. A new developer has taken over the second phase of construction of GEOS and is attempting to install gas lines, even though the entire design works perfectly well without fossil fuel power. Fortunately, the residents have really taken it upon themselves to create a grassroots resistance and to promote the continued development of GEOS in this net zero manner. However, even though there are these challenges in well-resourced areas, understanding that most of this growth I discussed before is anticipated in places like Africa and Asia, in middle-sized cities where resources and infrastructures are less available, I realized I needed to study more locally integrated ways of producing these carbon neutral and energy secure buildings and cities of the future. So for my master's, I moved to Spain, to Barcelona, and specifically to the Institute for Advanced Architecture of Catalonia's Valdara Labs facility. Valdara Labs is really an incredible estate surrounded by this red line you can see here pictured, which comprises 135 hectares of forest within the Collserola Natural Park. The Collserola Natural Park itself, this large green area, is about 20 times the ground area of New York Central Park, which gives a sense of scale of how valuable of an ecological resource it is, and a true green lung and many other functions for the city and urban region of Barcelona. Valdara is anchored by a historic masía, which is a Catalan farmhouse created in 1888, but has since been renovated to host a fully fitted digital fabrication lab, including laser cutters, 3D printers, electronic prototyping equipment, and a more traditional carpentry lab with industrial tools like a planer, a table saw, a bandsaw, and in the back a CNC shopbot as well. These combinations of tools are critical because what they allow Valdara to do is to act as a holistic metabolism, taking energy and materials from the forest all the way through manual processing, digital processing, to create advanced building products and eventually even advanced prototypical buildings. So the lab is not bounded by the walls of this building. In fact, the lab includes those 135 hectares of forest as a singular integrated metabolism. The theories at Valdara and the practices are based on the teachings of the directors and their works, such as the idea for the self-sufficient city, an integrated network of networks that comprises rainwater catchment, greywater recycling, waste recycling, energy production, bound together within the network of a city block, able to be exchanged between buildings for resilience on that scale, as well as exchanges between blocks to create, again, this true network of layered networks for resilience and efficiency and the optimization capacity of being able to move things from where they're generated to where they're needed in a organic and bottom-up method. This is also supported by concepts of wood urbanism, promoted by another director of the lab, Daniel Ibanez, from the Harvard GSD, which emphasizes the potentials for timber and mass timber in buildings, not only for the new design capacities, the materials so light and dynamic as timber provides, but also for the carbon sequestration potential and that relationship to energy and the embodied energy of the materials, and that throughout their entire value chain, because they are so light and carbon sequestering, we can reduce the invested energy in the production of the material and eventually the production of the building. There's actually 4 ways that we can think about this carbon sequestration potential of timber. One is substitution during life, as I mentioned in the introduction, by using a carbon sequestering material such as timber in place of concrete, steel, and glass. We avoid the carbon emissions and the energy intensity of those materials. We also have substitution at end of life, the fact that timber can be cascaded many times. It can be disassembled because it is light, it can be remilled because it is a soft, easily machinable material, and ultimately, if need be, it can be used for biomass or for composting, being an organic material. Of course, we also have the direct sequestration, which is the carbon captured in the timber itself throughout the growth of the tree's life cycle. And we also have the ecosystemic sequestration, which I think is really critical, which relates to the fact that by promoting the value of timber resources and creating sustainable forest management plans to produce those resources, we can create a forest which ultimately performs the ideal carbon sequestration as well as many other ecosystem services. Because while young trees sequester more carbon during their growth, mature forests with their soil diversity sequester much more carbon and therefore help us achieve a climate-stable planet. This concept of sustainable forest management is something I've not just thought academically about, but have practiced on the ground, again in my role as head of projects at Valdara. This estate might seem to be a very lush, mature forest, but that's misleading. In fact, it was recently cleared for agriculture. You can see here this photo from just 70 years ago. The entire landscape was terraformed and terraced in order to be able to plant. So what we actually have is a very new forest, which is dominated by pioneering species, especially the Aleppo pine trees, which do not provide the optimal diversity for life in the forest by shading out other more mature trees and shading out the undergrowth. So we work very closely with ecologists. Here pictured is Gerard Pasola, who also goes by Dr. Arbol, and is an expert in identifying trees that are suitable for building, but also trees which need to be removed so that other forest species can grow up. So for instance, by selecting the right pines to remove, we can allow the oaks to grow up below and create eventually a more mature system. Of course, the forest would do this in its own time naturally, but its own time is thousands of years, and again, as mentioned with these climate pressures, we only have decades to achieve these functions. So operating within the forest management plan of the park at large, we individually select trees which we know will be useful in our projects and our experiments, but which will also improve the health of the environment through the removal. We go through every step possible to record all kinds of data about these trees, to understand their biomechanics, but also to understand their role in their ecologies, and as well as to develop some aesthetic techniques and start to understand how these forms of the trees and the natural materials might and then inform the forms of the products that they are built from. The entire value chain occurs on site experimentally. We built this entire system comprising all of the tools and the workflows to harvest the trees, to keep track of them with simple techniques like paint color, to mill them into boards, to cure and dry them with sun and wind, and then to process them eventually into advanced materials like cross-laminated timber. Traceability is a key aspect which we maintain with simple techniques like paint here, but could be scaled up with techniques like RFID tracking or DNA sampling at a larger scale. And we prototype tools, also digital tools, to help architects understand where their materials are coming from, because we can only know how much energy or carbon is invested if we know the whole life cycle of the product. And geographic provenance plays a big role in that, as well as the material category itself. So we've developed these digital tools that help architects and non-specialists to see where things are coming from and the way that that affects their carbon sequestration or carbon emission ratios. And this helps us to prioritize a design, to understand that choosing things like local timber forest structure really does outweigh the things that we can't necessarily improve upon, such as the carbon invested in solar panels that are produced overseas. We also tell these stories in the building, so it's not just about optimizing, but communicating the reason for optimizing to the users. So we've developed augmented reality apps that allow you to scan building elements, see their trace back to their source of origin, either go back to that place to make sure that in fact removing that tree did have the intended effect on the surrounding ecosystem, but also to connect the user to that tree and to the material metabolisms of their space. Educating the next generation of design professionals is the only way that we're going to get these theories and these practices up to scale. So while I was at Valdara, I also, after graduating from the Master in Advanced Ecological Buildings and BioCities, helped to coordinate the program for the future editions. And we teach students here not just how to build, but also how to live in an international way. The program draws students from all over the world. We often have between 10 and 20 nationalities in the student group at any given time. Most of them live together on site for a full calendar year, so they see all of the ecological seasons, and they learn about growing food as well as others' traditions and communal life in addition to building and design. Every year this program culminates in a full-scale, one-to-one prototype of a real working building that is completely autonomous, completely off-grid, completely self-sufficient. These are small buildings because they're designed by students quickly on a low budget, usually within about 8 weeks for the design and the construction, but they embody these very large ideas. In our first term, when I was a student, I was able to serve as project manager because of my prior professional experience, but it was really a collaborative effort between all of our international students and the directors and a couple of staff members as well, adding up to this team of 13 nationalities that through charrette processes contributed all of their different backgrounds and expertise and creativity. We kept track of all the materials on site, enabling this traceability aspect that I discussed, understanding how we can apply then computational milling and other advanced techniques to achieve efficiency and new design capabilities, and carrying this through to every aspect of the building. So using timber for the structure, but also thinking about foundations that could be done with local materials like quartzite, so that the building can be disassembled at its end of life and the materials circulated without disturbing the site. Thinking about waste systems that can process human waste just with a microbiome of worms and bacteria to create compost. Recycled materials for insulation and membranes like cotton and rubber. combining advanced tools with low-tech tools, understanding what is best for the job, not just using the tool for the tool's sake, but for the effect's sake. And sometimes the effect's sake does require advanced tools when we're trying to achieve certain geometries that respond more to natural parameters or give a certain aesthetic, as well as to optimize in certain cases. Again, understanding that there are just a few students working on this project and our budget and time is limited, we need to make intelligent decisions in the same way that we need to make intelligent decisions when we're talking about large-scale projects and large budgets because of the resources involved. So creating scripts for optimizing facade panels and so on and so forth. Engaging our students also in every aspect of the metabolism. Most of these students have an architectural background, but here they're installing water systems, solar-powered water heaters, waste systems, photovoltaic systems, every aspect of the building's life and metabolism. And maintaining, of course, so that having an ecological building and an energy-sufficient building doesn't mean giving up your lifestyle or reducing opportunities in any way. These buildings are off-grid energetically, but they're fully connected with information. It actually serves as a weather station for the area and is connected by Wi-Fi to the network at the main house so that you can stay connected and live a contemporary lifestyle, though with all the benefits of being immersed in this incredible ecosystem. And here are the results of the first project, the new house. This was the project I managed as a master's student. Just some images to give a sense of context for the results and the way that it is integrated here naturally with the environment from which the materials came. Of course, acknowledging that this was a very collaborative effort, only realized thanks to the help of sponsors as well as instructors and other students. The success of this first year enabled me then as a staff member of Valdara Labs to oversee the next round of students in their construction of another prototype, here using cross-laminated timber in order to build fully off-site and rapidly deploy, as well as new finishing techniques based on the Japanese yakusugi tradition to protect the building from water, from infiltration of pests, etc., while maintaining full compostability and bio-based materiality. This resulted in the Voxel, a quarantine cabin, which was determined for the program because it was built during quarantine. So while most of the world was biding their time or working from home, our students, because we were able to self-isolate here in this community, were building on the ground with their hands, creating something that's truly beautiful and valuable for the world. And the results, I think, speak for themselves. It's quite a nice project. Again, also incorporating photovoltaics on the roof, as well as a small green roof and rainwater catchment system in this case. It should also be noted that the virtue of cross-laminated timber in this project is quite evident. We can see that this single system is able to serve as structure as well as a thermal and acoustic barrier and an incredible interior finish. Most recently, the third edition of the MIAB completed their final project, another international team, this time thinking about energy, not just in terms of the energy required to light a building or to run its operation, but also in terms of the energy that we have to digest as humans to stay alive, and food energy, and the relationship between electricity and calories, understanding that energy is not just electricity, but it's all kinds of different forces. So again, we went through this process of constructing on-site all of these various prefabricated components to create the solar greenhouse. This is a facility that leverages both passive conditioning with its orientation towards the sun and ventilation with the production of energy through these photovoltaics that still allow enough transparency to perfectly grow plants below and are able to power the the lights as well as the irrigation system for all of these plantings. And here you can see this embedded in our gardens at Valdara and its role in this productive ecosystem. Also maintaining beauty, understanding that nothing is sustainable if people don't desire it, and so beauty is always an utmost priority. By scaling these small prototypes up to larger regions, we can really make an effect on the world. We can think about local forest resources like we've done in partnership with the municipalities of Catalonia. We can also think about the way that these might combine these different technologies and sort of buildings into urban systems at scale in places where growth is anticipated, like in China or Africa, adding up to a worldwide circular bioeconomy as promoted by the European Forest Institute, and which we have also supported and developed through authorship and co-authorship of texts that help policymakers, that help academics, that help designers understand how to implement these theories in the real world. The Green Book of BioCities is one particular publication I was able to co-author in partnership with such notable architects as Stefano Boeri, as well as groups like the Politecnico di Milano, the European Forest Institute, the USDA, and a number of other notable organizations that are really promoting and pushing forward these theories. So I thank you very much for your time in watching and listening and for your consideration of my application. I hope to meet you soon in Madrid.